class, we went over tangent. So I'm going to go ahead and go over this. If you understood how to use tangent, sine and cosine are very similar, meaning if you remember SOHCAHTOA, you're good. Looking at this first question, it says, find the tangent of the acute angles in the right triangle. Write each answer as a fraction and as a decimal, round to the fourth digit. We're just going to do it as a decimal. We're going to solve it as a decimal. So looking at it, tangent, we're finding the acute angles. We're finding two of the angles. We're finding angle S and we're finding angle R. Most important thing for tangent is if we remember SOHCAHTOA. Okay, looking at SOHCAHTOA, tangent is opposite over adjacent. So looking at R, angle R, okay, I'm going to write it as tangent R. What's opposite to angle R? Anybody know what opposite to angle R is? 24. Good, I'm going to do 24 over, what's the adjacent to angle R? It's the 10. Why is it not the 26? Good, that's the hypotenuse, and I'm not using my hypotenuse for tangent. So that's for angle R. Let me go ahead and find angle S. Tan S equals what's opposite to angle S? Anybody? What's opposite to angle S? 10, and what's adjacent to angle S? Good. If I'm finding the angle, am I going to use the inverse? Yes or no? Yes. Okay, anytime you're solving for angle, you have to find the inverse. So looking at tan R, what I'm plugging into the calculator, tan inverse 24 over 10. Go ahead and plug it in if you have a calculator. I did not bring the calculators, so you're going to have to share. Tan inverse, so hit second tan, and you're going to do 24 over 10. Rounding to the fourth digit, angle R is 67.3801 degrees. So going ahead and doing tan S, you're still doing the inverse. I'm sorry?
So on the calculator, you put tan -1 24 over 10.
Yes. So yeah, you're going to put the inverse in. So for this one, hit second tan, 10 over 24, and then click enter. For angle S, what are you going to get? What do we get for S? Do you guys have your calculators?
Yeah.
All right, if you do have a calculator, you need to be plugging them in. 22.6199 degrees. I'm not always going to have my calculators. You guys have to bring your own.
I got it, Chung.
All right, next. We're just doing sine and cosine.
Apple calculator got 10.
You can't use that on the test or quiz. You don't even, there's no inverse. We're using inverse. All right, looking at sine and cosine. This is just the general rule for sine and cosine, but I want you to write on your notes just so we understand. I'm going to have SOHCAHTOA. I need to see this on there. SOHCAHTOA. And the S stands for what? I'm going to have sine equals opposite over hypotenuse. Your cosine equals adjacent over hypotenuse. And your tangent equals opposite over adjacent. Okay, so if you're looking at what SOHCAHTOA is, it's the setup of what each of them equal. Okay, so please make sure you're understanding that, because once you know this, it's pretty easy to solve for these. So please write this on your slide, what everything equals. And we're just going to transfer that to the next slide. You're just going to write it on the next slide as well. So looking at the next slide, go ahead and write it out. Okay, so they're giving you SOHCAHTOA at the top if you forget it. I'm writing it out. Sine equals opposite over hypotenuse. Go ahead and do cosine and tangent. Go ahead and fill those in on your own. All right, you should have filled in cosine equals adjacent over hypotenuse. And then tangent is opposite over adjacent. Okay, that's something that we should all memorize. All right, we're going to go ahead and solve some of these. So when are we using it? How are we using it? What goes where? So I'm going to do these questions. And again, I'm writing SOHCAHTOA on here just so I have it because you're going to need it to refer back. So SOHCAHTOA. And solving for angle A. I'm going to be doing sine A, cosine A. I'm just writing them as a fraction. And tangent A. So here's angle A. And sine is what over what again? You could tell me. Good. Opposite over hypotenuse. So looking at angle A, for sine, what's opposite to angle A? Good. And what's the hypotenuse? Good. That's all I'm writing for this. I'm just writing it as a fraction. Looking at cosine A. So I'm still looking at angle A. And what's the adjacent side? 4 over what's the hypotenuse? Good. And then looking at tan A, what's the opposite side to angle A? And what's the adjacent side? 4. Okay. I just want to clarify. This A does not mean, this A doesn't stand for angle. Okay. Anything that's here next to your sine, cosine, your tangent is going to be your angle. This is your angle. Okay, so sometimes they're giving you a letter because you're finding an angle, or sometimes they're giving you the angle. And as we go into some of the examples, you see some where they're giving you the angle and you're going to have to find a side. So for this type of question, we could solve for the missing angle if they were to ask us solve for the angle. Okay, let's go ahead and go to B. So now I'm finding sine B, cosine B, and tangent B. So looking at my B, here's my angle B. Who could tell me sine B? What do I have to find? Opposite over hypotenuse. And what's my opposite of angle B? Good. And what's my hypotenuse for angle B? Good. And then looking at cosine, I need my adjacent side. What's my adjacent side? 3 over, what's the hypotenuse? Good, 5. And then tangent, I have opposite over adjacent. What's opposite to angle B? 4 and adjacent? 3. So to be kind of understand how we're getting these, you have to understand and remember, it has to be a right triangle. It's always going to be for a right triangle. All right, this is for sine and cosine of complementary angles. What does complementary mean? Equals adding 2 angles to equal 90 degrees, and we'll eventually use these as we get into some of the examples. All right, we did these last class with tangent. If you have a calculator, for those of you that have a calculator, please try and share them. Sorry I didn't bring my calculators. Sine 30, just plug that into your calculator. I'm not using any inverse. I'm not using any of that for these. I'm just going ahead and figuring out sine 30. Please round to the nearest tenth. I'm sorry, not tenth. We'll do hundredth, David. Hundredth. Round to the nearest hundredth. And then for C and D, round to the nearest whole number. Remember for C and D, because you're solving for your angle, you have to use the inverse. When you're solving for your angle, you have to use the inverse. So looking at these, sine 30, again, calculator, plug in sine 30, and it's going to be 0.5. Looking at cosine 45, again, plug that into your calculator. Rounding to the nearest 42, I'm sorry, 42. Round to the nearest hundredth, it's going to be 0.74. For C and D, when you're plugging this one in, you have to plug in the inverse, 0.1045. And then for C, your cosine, you're also doing the same thing. Inverse cosine, 0.9659. So when you're plugging in the inverse, you have to click second sine, 0.1045. And rounding to the nearest whole, you're going to get 6 degrees. And then for cosine, again, you're using the inverse, 0.9659. And that's going to give you 15 degrees. All right, looking at example number 3. Now they're giving you the angle measures. Now I have to figure out, am I using sine, cosine, and tangent? So again, I'm going to write SOHCAHTOA so I have it here. SOHCAHTOA. And I'm using 28 as my angle. So this is the angle I'm looking at right here. And this is what I'm going to be using for both of them. So in order for me to figure out, okay, am I using sine, cosine, and tangent? I have to look at what I'm solving for. So for the first one, I'm going to go ahead and solve for x. Looking at my x, what side is my x considered? So what side would this be considered according to my angle?
The opposite.
Good. So I know, looking at it, I know I'm not going to be using my cosine. And then they're giving me my 1,000. What is that considered?
Adjacent.
It's not my adjacent side.
I mean hypotenuse.
Good, it's my hypotenuse. So because I have my opposite and my hypotenuse, I'm going to use sine. So how am I setting this up? I have sine, what's the angle? 28 equals opposite, which we said was x, over 1,000. Now, going back to algebra, how can I get my x by itself?
Multiply 28.
Not multiplying 28.
1,000.
Good. Multiply both sides by 1,000. So again, all you have to do is plug it into your calculator. 1,000 times sine 28. Click enter. They want us to round to the nearest whole number. So looking at this one, what would my answer be if I solved it correctly? 47? Nope, not 47.
Wait, whoa, you said 1,000?
1,000 times sine 28. What would my answer be?
28,000?
Good, 469. You're going to have a hard time on the phone. Sine 28. All right, now next, I solve for x. Now I'm going to go ahead and solve for y. Here's my y. So again, according to the angle, what side is my y considered? My adjacent side. So I know I'm not using sine anymore. If I have my adjacent and my hypotenuse, I'm going to be using cosine. So I'm now going to have cosine 28 equals y over 1,000. Doing the same process, how do I get rid of that 1,000? Multiply both sides. Good, thank you. And then plugging it into the calculator. Yes, I'm going to have a different answer because I'm not using sine, I'm now using cosine. If you plugged it in correctly, x equals, rounding to the nearest whole number, 883 would be your answer. Okay, you guys have to double check which one you're using because it does matter.
What do we plug in?
1,000 cosine 28. Kinsley, you had a question?
Oh, never mind.
Okay.
Wait, it's 1,000 times.
Cosine 28. All right, for this one, they want me to find the degree. Again, what am I going to write? I'm going to write my SOHCAHTOA. SOHCAHTOA. All right, according to the angle that they're giving me, I'm solving for x. What do I have? Do I have my opposite, hypotenuse, and adjacent? Which one do I have? I have my hypotenuse and my opposite side. So I know I'm going to be using sine. So I'm solving it as sine x equals my opposite side over my hypotenuse. Do I have to use the inverse? Yes. Why do I have to use the inverse? Because I'm solving for the angle. Anytime you're solving for the angle, you have to use the inverse. So looking at this one, because I'm solving for the angle, I'm plugging into my calculator. The inverse of sine 18 over 30. So second sine 18 over 30. And they want me to round to the nearest degree, so I'm rounding to the nearest whole number. What does my angle equal?
37.
Good, 37. Don't forget your degree sign, please. 37 degrees is x. All right, we're almost done. Looking at number 5. Find the measure of the 3 angles, round to the nearest tenth. Is this a right triangle? No. When you're solving using trigonometry, sine, cosine, tangent, they must be right triangles. How could I make this a right triangle? All right, all you have to do is cut it down the middle. So slicing it down the middle, I just changed it to 2 right triangles. What are the bases of my 2 right triangles going to equal? Yes.
How do you know?
2 and 2.
How do you know it's split? Like
When
why?
it's not a rectangle.
I'm going to make it a perpendicular line. So looking at it, it's an isosceles triangle. How do I know it's isosceles?
I saw something. I don't know.
How do I know? Because 2 of my sides are the same measure. So because it's an isosceles, I could split it down the middle and make a 90-degree angle, perpendicular lines. So now I can solve for 2 angles. The 2 angles I can solve for is C and B. So here's B, here's C, and again I'm going to write my SOHCAHTOA. All right, I'm going to solve for C first. Angle C. What do I have for angle C? Looking at just angle C. Andres, face forward, please. What do I have?
2 and a 5.
A 2 and a 5, but what are those considered? Andres, face forward. I have my adjacent side and my hypotenuse. So looking at it, which one am I going to use? Good, I'm going to use my cosine. I have cosine C, because I don't know the angle, equals my adjacent side over my hypotenuse side. So plugging it into the calculator, I'm going to do inverse cosine, 2 over 5, and I'm going to get 66.4. All right, looking at angle B. What do I have for angle B?
They're calling you, Kyle.
What do I have for angle B? I still have my hypotenuse, and my adjacent side, so I'm still doing the same thing. Cosine B is 2 over 5, and yeah, I'm still going to get 66.4. Now I have to figure out a way to solve for A. Just think of this as a normal triangle, okay? I have my 2 angles and I'm missing 1. How do I find one missing angle on a triangle?
You add the 2 and then you subtract 2, right?
By what?
20.
Perfect. Go ahead and add them.
Good job.
66.4 plus 66.4. Add both of those together. You're going to get 132.8. And then subtract that by 180. 180 minus 132.8. And solving it, you're going to get 47.2. So angle A equals 47.2 as your answer for angle A. Questions on this one? All right, solving sine and cosine in special right triangles. Looking at this, knowing SOHCAHTOA. Again, plugging in what I have. I'm just writing it on here. SOHCAHTOA. I'm going to do sine first. I'm using 45 degrees. So I have sine. Are you even taking the notes, Austin? Write it down. Sine 45 equals what over what? What do I have to have for sine? Opposite. My opposite side is 1. Good. And what's my hypotenuse? Radical 2. Can I have a radical as my denominator? No, I cannot. So I need to multiply top and bottom. So my answer is going to be sine 45 equals radical 2 over 2. And that's it. Now I'm going to go ahead and go to cosine. All right, for cosine. Cosine, see if you could borrow a charger, please. Cosine equals, what do I have for cosine? Where's my adjacent side for angle 45? I'm going to have a 1, radical 2. Again, I cannot have a root in my denominator. So I'm going to have cosine 45 equals radical 2 over 2. Go ahead and do sine and cosine for 30 degrees on your own. All right, check your work for sine and cosine of angle 30. That's it. You're not going to simplify it. There is no simplifying it here. Good job. All right, angle of depression. Last class we did angle of elevation. Now depression is going from the top to the bottom. So looking at this question, it says, you are skiing on a mountain with an altitude of 1,200 feet. The angle of depression is 21 degrees. Find the distance x you ski down the mountain to the nearest foot. Go ahead and try and set this one up by yourself. Don't try and solve it. Just set it up. What would it be? Sine, cosine, tangent, and where would your information go? So I'm going to go ahead and write SOHCAHTOA here for you. This was not on yesterday's note. Yes, SOHCAHTOA, yes. Yes. All right, what do I have? According to my angle, this is my angle. Looking at it. Bruce, what is my 1,200 considered? What? My opposite angle. It's considered my opposite angle. So am I using cosine? No, there is no opposite in cosine. Sebastian, what is my x considered? It's not your opposite angle. It has to either be your hypotenuse or your adjacent. Which one is it, Kyle? It's not your adjacent. It's going to be your hypotenuse. So I know I'm using sine. You guys for that need to pay attention. Here is your 90-degree angle. Your hypotenuse is always opposite your 90-degree angle. So looking at this one, setting it up, you're going to have sine 21 equals, what is your opposite side? Boys, stop. What is your opposite side? What did we say the opposite side was? What was it? 1,200 over x. All right, so solving for x. You cannot just multiply by 1,200. You can't do that. Following it in steps. I'm trying to get rid of my x. I'm going to multiply both sides by x. Okay, multiply both sides by x. Then I'm going to get rid of my sine by dividing it on both sides. So what it should look like when it's neat. X equals 1,200 over sine 21. So this is what I would have. Plugging it into your calculator. They want you to round it to the nearest whole number. I'm going to have 1,200 divided by sine 21. If you plugged it in correctly, your answer is going to be x equals 3,349 feet. And that's your answer.